that note card, you do get to, so the clarifications we need to make, because I can see that I have a couple of soon-to-be paralegals or attorneys. My verbiage yesterday was you could put anything on that card as possible. So someone pointed out, well, I could just glue my phone and it would be on it, and that's what it said. So you can write anything you want on that, tape anything. If you had like went online and had like 0.2 font, you can tape that to it. You just can't tape multiple pages where you have a flip chart.
Wait, sir.
Yes.
So let's say like I have this piece of paper and I fold it up, and then can I glue it up and put it on there?
Yes.
If I like fold it up.
No. It can't. It has to. It has to say the size of that card. Okay. But you could fold it over. You could wrap it in that piece of paper if you wanted. Yeah. Or you could shrink that piece of paper down and tape it. But if you have something taped down, you can't have it as open it up and then you have the back side of that and then the card.
Just the two sides.
So that's what we got. So if when we come down to taking the final, which will be very last final, get your cards out. If you have something that you know is not appropriate, it's either you could use it or sorry. So if you feel that you want to challenge it and see if you want to bend the rules a little bit, might be the wrong idea. You might not be able to use something for you. Yes.
Can you get like a piece of red plastic and a piece of blue plastic and write everything in red and then write everything over in blue and then you have like two cards because you cover it?
That's.
Wait, I'm so confused.
Yes.
I don't get it.
I get it.
Oh, the 3D.
You're trying to make a three. That sounds really cool, and I'd like to see it done, but I'm not going to let you use it on the test. Should have asked him. All right. So I am pretty sure that review number 1 is done. There is no questions you probably have any longer on review number 1. Everything that we've done. And I think review number 2, we are probably in the same boat. But let me just pause there to make sure I'm not leaving or shortchanging anybody. So review 1 or review 2. Just make sure I'm not shortchanging anybody. Yeah. He can't use this on
Oh my God.
This is for history.
If we were to cut this out, can we use this?
Sure. If you tape it onto that sheet, sure. But you can't have it as a flip where it's like that's up front and then underneath is written. It was something I had posted on Schoology a while ago. It has the 30, 69, 45, 45, 90. You already know that. Yo, Phil! Okay. Review number 3. Review number 3. So reviews 1, 2, or 3. 1, 2, or 3. I gotta build you. Thank you.
Wait, I still don't get it.
I don't know. He does like
14 review 3. You got it. So number 14 on review 3 was asked for. It's the kite. I think we've done this all right, but it's okay. We'll throw it out there. So we have this kite. So things that we want to find is, I think we want to find this, so you know that has to be 15 by definition of a kite. ADC, oh, they told us this was 30, so they want the whole angle, so the whole angle has to be 60. And then ABC, so to find this last angle here, if you know that's 110, you know this was 110. 110, 110, and 60, that's 220, 280, so you have 360 minus 280. So you find that this last angle here is 80 degrees because it's 360 total. Any more up to number 3? Yeah.
19.
19 on review 3.
Yes.
Okay, find the slope of AC and BD. That. This. They tell us this is point A, 0, 0. Point D is A comma 0. Point C is A comma B. Point B is 0 comma B. And we want to find the slope of AC. Find that slope. And find this slope. Okay? So slope equation's this. This might be a good one to write on your card.
Oh yeah, I got that, bro.
Sweet!
Got it on my card.
So if I find that slope, it's going to be B minus 0 and A minus 0. So B over A is the slope of segment AC. And then if I find the slope of this one, if I find this slope here, I am going to go 0 minus B and A minus 0. So that's negative B over 0, which is segment BD. All right. Wait, hang on. I goofed. Oh, that should be an A. I'm sorry. All right.
Is that all they asked on that one? Or is there more on the next page? That's it?
Are those slopes perpendicular? B over A and negative B over A, is that perpendicular slopes? No, they might be opposite sign, but they're not reciprocals. So, is that okay? Anything else on 1, 2, 3, 4? Go ahead.
Number 16.
4, number 16.
Okay, we did that yesterday, but I'll do it again. So if the one looks similar to this, if it looks similar to this on the review, it'll probably look just like this on the test. So we know this whole distance here is 16. We know this whole distance is 14. And we know this whole distance is 10. Other things we know, they said that this is x. So this distance here has to be 16 minus x. Is that okay? So if this distance is x, then this distance here also has to be x. So then this distance has to be 14 minus x. Is that okay? So if I have 14 minus x here, 16 minus x here, then go purple. That has to be 14 minus x. And 16 minus x. So if I go this plus this, I'll get to 16. Cool. If I go this plus this, I get to 14. So that doesn't really help me. But if I take 16 minus x and add it to 14 minus x, that'll equal 10. So that gives me 30 over here minus 2x equals 10. Subtract 30. Oops. 20 divided, so x is equal to 10.
So you use the bottom set. This
Right.
is- okay.
Because, and the reason I do that is if I go this plus this, the x's cancel out at negative 14. If I go this plus this, the 16's cancel, or x's, so I get 16. But if I add these together, the x's don't cancel out because there's. Yeah. Random. Me? Have we seen it yet on the review? I don't know. I'd say throw it on there just in case, but we haven't seen it on any of our reviews yet, so I would hate to say yes and not have it, or yo.
I haven't looked further in the review, but do we need to know the properties of shapes?
I think that would be important. The way I would see it asked on the test would be if you have, maybe it says if your diagonals are equal and perpendicular, what shape? And it would list 4 shapes, and so you'd have to decipher what's the most exact on that. Yo. Number 8 on same review? Yeah. I sure can. All right. Number 8. Get this. And just so you all know, I'm recording both this period and next period, just in case there's an overlap of any questions. I'll also put on Schoology the slides to this that I'm doing. So, all right. So, being this is inscribed, this angle here being 80, and this angle here, do they both open to the same amount of the circle? So you just saw it, didn't you, Devin? So y is equal to 80. But now does it make sense?
Yeah, a bit.
So, yeah, and then if I did the x opens this way, right? And then opens this way. So x opens this whole angle, and this opens the same thing. So x equals 80 and y is equal to 110. Or, excuse me, flip-flop what I just said. Y equals 80 and x 110. Yeah. Because they open to the same amount. So think about where this point is right here. That's what x opens to coming this way, like that. And then this opens to the same point. Yeah.
Don't they? Aren't they equal to 180? 110 plus y equals 180.
Oh, wait a minute. Was it? Oh, wait a minute. Wasn't there a rule if it was inscribed in a circle? If it was a 4-sided object inscribed in a circle, the opposite values had to equal 180? Is this it? Okay. And then, sorry about that. I like the other way better. I'm going to make the stirrup rule. It's like, it doesn't really go with math. My teacher said so. There it goes. Okay, so if it's inscribed in a circle and it's a quadrilateral, the opposite values have to equal 110. Or the opposite values have to equal 180. Okay, yes?
Can you do number 14 on review number 2?
14, review. Yes. So we're solving for x. So this is off review number 2. Okay. What, according to that angle, does this appear to be an adjacent side? And this appear to be the hypotenuse? So adjacent and hypotenuse. Go with cosine. So you go cosine x is equal to 12 over 15. And so from there, I'm going to go x equals, make sure your calculator's in degree. Second cosine of 12 over 15. And that should work out. Cool? Yo!
17 and 18, just like
On what one? 4?
Also, is there an equation for 19 on that same review?
Yeah, how about I do 17, 18, 19 on this? So 17, we got a circle. This is 8. This is tangent, so that forms a 90-degree angle. This out here is 2, and this is x. Okay, so on number 17, if this part here is 8, how far is this part right here got to be? 8. So how big does this whole side have to be? 10. So this looks like it's a 3, 4, 5 doubled, so x has to equal 6. If it wasn't a 3, 4, 5 double, just use the Pythagorean theorem to find it. 18 you need me to do?
Yeah.
18? Alright. So they tell us this is x, and this is 4. And then they tell us this is 6. Okay, so if this is x, how long is that? X. How long is this whole side? X plus 4. So Pythagorean theorem will work well. So I'm going to FOIL that other side out. 56. Subtract the x squared so they cancel out. Subtract the 16, so that becomes 20 equals 8x. So x has to be equal to 20 over 8. And that reduces to 5 over 2. Right? Is that what the answer is supposed to be? Good. Then number 19. If I recall number 19 from our good old testing days, this was one of your faves. Just kidding.
Is there any type of like equation or like main thing to realize like
You doing this one?
So easy.
Sum of the interior n minus 2 times 180. All right, so things to recognize here. Those form 90-degree angles, yes? And then if this is a distance of 6, and this is a distance of 3, and the distance from here to right here is 2, we also know this distance here has to be 3, this distance here has to be 6, right? So the whole distance, so that whole distance right between those, that's kind of a bad one, I'm not going to do that. So then the whole distance is got to be 11. Is that okay? So I'm going to complete my rectangle now. So I'm going to bring this down. Is that all right? 90.
You got 3.
How far is this distance right here? 3. The reason this is 3, not because I'm drawing another radius. I'm trying to get from 3 to 6, so I'd have to have 3.
3 squared plus x
So
squared.
we're trying to look for that, so that's down there. So I have x squared plus 3 squared equals how much?
11 squared.
11 squared.
9, what is that, 110?
121. X equals.
Yeah,
that 1?
Smaller number than 121.
1,
Ooh, I can put that less than 121.
1, 12.
12.
Is that it?
Yeah.
And that's what x squared. So if you take the square root of both sides, 112 breaks down to 7 times 16, I believe. Am I right with that? So that's then square root of 4. So I get x equals 4 root 7. Yep. Alright, they tell us that from A to B, this distance here is 30, and E to F, this distance here is 10. So we want to find angle G, so we're looking for this one, and CD, and we're also looking for this. Okay? So I'm going to look at the big circle. I'm going to ignore the small circle in here. So I have this angle here. This comes all the way back to this angle here. Okay? This angle is not an essential angle, so this angle has to be what part of 30? It has to be 15. So this is a 15-degree angle now. Is that okay? Now I can ignore the big circle, and I can look at the small circle. So I know that this angle here and this angle here, so I call that x. If I go x minus 10 divided by 2, that'll be equal to the exterior angle of 15. So that's x minus 10 equals 30, x equals 40. So that's 40. Which looks weird that, why would this be only a 30-degree angle and this is smaller being 40? It has to do with how much the angle is open. It doesn't have to do with the actual arc length. Yeah? 2 on 5. Find the area of each, okay. That's 8, that's 6. So in order to find the area of a triangle is 1/2 base times height. Base and height are always perpendicular, so I have to figure out what this is. So Pythagorean theorem will work for us. 64 minus 36, 28. So question mark is equal to square root of 28, which breaks down to 2 root 7. So if that's 2 root 7, now my base and height are 6 and that, so I have 1/2. Area equals 1/2 base and height. So let's cancel there. So I get 6 root 7 square units. Cool. 3, same thing. Okay, number 3 is going to use Harans or heroes. Okay. So remember, I have to find the partial perimeter. So that's all the sides added up, divided by 2. 12, 20. So my S value is 10. So remember, that's my partial perimeter. I'm now going to use that to find my area. Right? Doesn't matter which one I label A, B, or C, just as long as I put it in there. So I get 10, and then 10 minus 6 is 4, 10 minus the other 6 is 4, and 10 minus 8 is 2. So that's 40, that's 160, 163.20. Root 320 is my area. So I could probably break 320 down. See, I'd say 4 goes into that 80 times. 4 goes in that 20 times. 4 goes in that 5 times. Square root of, square root of, square root of. So 2 times 2 times 2. 8 root 5, right? 8 root 5 square units. Yo.
I don't know, maybe if you were listening, you would know, Devin.
Yeah.
Wow.
8. Boy, Devin, you're a rough crowd, pal. Number 8 off review 5. All right, Devin. 8 off review 5. Find the area of each. So we have to try and find the height. Okay, so here's my height. I'm just going to draw it in. Okay. So if this is a 60-degree angle, and I know the hypotenuse, if I go this way, I'm going to have to go 6 divided by square root of 3. Yeah, because this down here, this would have to be, that would have to be 3. So if I reduce that, that becomes 3 root 3. Okay, so my height is 3 root 3. In order to find the area of this, I have base times height, so my base would be 11. My height would be 3 root 3. So I get 33 root 3 square units. Yeah.
How'd you get to 3 on the bottom?
Oh, because this would have been a 30-degree angle here. So hypotenuse opposite.
Gotcha.
The whole review is wide open, so anything you see. Yeah. 17 on 5. 17 on review 5. We want to find the area of the shaded region. Okay. So let's find the area of the circle first. Area is equal to pi r squared. So I get 36 pi square units. That's the area of the whole circle. Now I have to take the area of the equilateral triangle away, but I happen to just know the radius of that. So if this is an equilateral triangle, each of these angles is 60, agreed? So that means this is 30 and 30. So if I draw in my apothem, I have the hypotenuse being 6. So this triangle blown up is going to look like this. So I want to figure out my apothem. What is my apothem going to be if I know the hypotenuse? Opposite of 30 has got to be what?
Oh, yo, I got this
3?
one here, right? So,
So if this is 3, then could I use this equation? Could I use that equation? It is a it's polygon. So my apothem is 3. Number of sides, it's a triangle, so it has 15 sides, right? And then the length of each side. Oh! How long is this side? That's 3. 3 what? Root 3. So if that's 3 root 3, how long is the length of this? 6 root 3. Good. So 6 root 3 goes here. So let's see. That goes in 3. So this appears to have an area of 27 root 3 square units. So if I subtract these from each other, I get my area, of my shaded region. So 36 pi minus 27 root 3 square units is the area of the shaded regions. Yeah.
I have a general question. So with law of cosines, like how would the triangle be set up for the equation?
The law of cosines? Okay, so law of cosines works when you have all 3 sides given and you're trying to solve the rest. So if you had like 4, 5, and 6, law of cosines, you could use that to find any of the angles. Okay? It also works when you have 2 sides and the included angle. So the angle, included angle. So if you had something like this, if this was like 70 degrees, that was 10 and this was 6, you could then start figuring out, that would then solve that side, and you could then.
Okay. Also one other question.
Yeah?
So when you're doing like sine or cosine or tangent of like an angle, how do you find the angle if you have the?
If you want to find the angle, you have to do the second of it. So if it's a right triangle, let's just draw a couple right triangles. So let's say I'm looking for x, and this is 6 and 7. Let's say I'm looking for x, and I have 5 and 9 or something, I don't know. And then let's say this is x, and I have 6 and 3, even though it doesn't look like it. So this top one would be sine x equals 6 over 7. So you'd have x equals second sine of 6 over 7. This one would be adjacent to that, so that's going to be cosine x equals 5 over 9. So x equals second cosine of 5 over 9. And then this one would be opposite and adjacent, so I have tangent. Yes, you could reduce that to 2 and it would still work. Okay. Yeah. 9 on number 6. That's the lampshade looking one.
Find the surface area and volume of each.
All right, so surface area real quick. Let's see what we do. I think I would complete this cone and figure out what the height would be. So this is going to form a right angle, so that's 16. This whole side here is going to be 19. So if I'm looking for my h, I have 16 squared plus h squared equals 19 squared. I need help in more than one way. 16 squared is what? 256, and 19 squared is how much? How much? 361. 361 minus 256 is 361 minus 256. 105. So I find my height here is the square root of 105. We'll worry about saving that later. All right, so to find the surface area, I have pi RL minus pi RL. So I'm going to do the big cone minus the small cone. So pi RL of the big cone, that's pi 16, L is 19, minus pi R of the small cone is 4, and the slant height is 4. It also happens to be 4. Okay, 19 times 16. How much? 304 minus 16. 288 pi square units. So that's the surface area. Oh wait, I'm not done with the surface area. That's the lateral surface area, agreed? What else do I need to find? I have to find the two bases. So then I have pi r squared plus pi r squared I have to add to it. So I have the two circles. So I have 16 pi here plus 256 pi here. If I add those together, I get 272 pi plus 288 pi is 560 pi. Thank you. Bless you. So that's the surface area. Bless you. If I wanted to find the volume of the whole thing, I'm going to go big cone minus small cone, so 1/3 base times height. Okay? So I have to do that twice. So I'm going to do the whole cone. I get the whole cone, 1/3 area of the base is pi r squared. So pi 16 squared. What's the height? And then the small cone is 1/3 pi times 4 squared. Oh shoot, what's that height?
Oh wait, no, sorry.
I don't know what that height is. I don't know what that height is. What's that?
It says the height is 572, or the surface area is 572 high. The answer is 572 high.
And we have 560 pi, huh?
Wait,
Yeah.
did you use 4 for the radius and the height?
Yeah, that shouldn't happen. Because the radius is 4.
We know the height. Is that total height or total slant?
Oh, dude.
That's 20.
I goofed that.
What is that?
Oh, so the whole thing.
Yeah. I discovered that in the middle. So it's incorrect there. It's incorrect.
What would that number be then?
Yeah, how do you figure out?
How would I figure that out?
By the sine cosine of the tangent of the hypotenuse. Multiplied by the radius of the cone.
You multiply by the volume of a perpendicular triangle.
Then you find the what is it? Moles.
And then you use foil.
You gotta convert the mole.
You gotta convert moles to volume of a gas.
Stop.
I gotta think about this. Give me a few minutes. I'll figure it
Bro,
out.
I just told you the answer.
You gotta use Avogadro's number. 6.023 times 10 to the 23rd.
No, it's actually 6.0.
You gotta use that. That's Avogadro's number.
You know, Euler, O-I-L.
No, you use Bohr's theorem.
Euler.
No, you use Bohr's theorem and then Avogadro's number.
You gotta use Euler's theorem.
Let's go, Cam.
Perfect. All right.
No, wait.
I'll figure this one out for you. I'll have it on the video if you want to see it.
Hey, my friend's an Ethiopian.
It's just the drawings get worse and worse. I handwrote everything.
Sorry. Lee, I'm recording again.
Oh, okay, got it. I won't.
All right. I want to go over.
That's a way to start it.
This is number 6 from the review number 6. It's this problem. It looks like a lampshade. And I don't know if you're going to have one on there, but I want to make sure we go over it. You know, I wouldn't waste, number 9, thank you. My dyslexia is working well. I'm flipping numbers around. Okay, so that's all the information we have given, right? Agreed? So let's think about other things that we could do to this problem. I could draw down this altitude just like this, and that would then tell me that this distance right here would be how far? 4. So if the whole distance was 16, how far would this distance then be here? 12? Agreed? So we know they had told us that this whole distance here was 16, but we can decipher that. So then you realize you should be able to recognize that this is a 345 multiplied by 3. Okay? So if I divide that by 3, I get 5. Divide that by 3, I get 4. So this is going to be a height of 9. Is that all right? So then with that, I can then draw this height right here to also be 9. Agreed? Anything about that that's not making sense? All right. So now I'm going to draw the rest of the cone in. Okay? I have a height there that I don't know. But the cone on top and the whole cone have to be similar. So if I go h over 4, this over the radius, is equal to, how long is this whole distance then going to be? H plus 9, good. Over 16. Does that make sense so far?
Yeah.
Cross multiply, so I get 16h equals 4h plus 36. Subtract that, I get 12h equals 36. So h is equal to 3. So now I know this height right here. Do I know this slant height? It's 5 because that's a 3, 4, 5 triangle, correct? Is that all right so far with this whole problem?
Yes.
So that finds you everything about this problem. So now we can work on this problem and take a look at the surface area. So what I'm going to do is I'm actually going to take this here, highlight it, and I'm going to move it down here.
Oh.
There we go. All right. So it's down there. It's still part of the slide, so I can see it. Come on, baby. Get out of there. All right. So it's still down there, so we can see it if we need to. So now, if I wanted to find the surface area of the black lampshade, I have two circles. I have a circle and I have a bigger circle. So this circle has a radius of 4. This has a radius of 16. So I have pi r squared plus pi r squared. So that's going to give me 16 pi, and that's going to give me 256 pi. And if I add those together, that's going to give me 272 pi. Is that right? So that's the area of the circles. Then I need to find the lateral surface area of the blue cone and then the whole cone and subtract them. Okay? So the entire big cone, that's pi RL. And then the small cone minus the small cone, which is also cos pi RL. So pi RL here, that's the big cone. I have 16 times, what's the slant height of the entire cone? How much? 20. So I get pi 16 times 20. So that's going to be 320 pi. So that would be if I had a whole big cone, but now I have to take away the top now. So the small cone, I have pi RL. So R is 4, L is 5, so that's going to give me 20 pi. And so then 300 pi is the lateral area plus our 272 pi, which is our area of my two circles. So if I add those together, I come up with 572 pi square units, and that's my entire surface area. Is that okay? Make sense? Then we have to find the area of this. Or, excuse me, no, not the area, the volume of it. I apologize. So now if I find the volume of the entire cone and then take away the small volume of the top cone, I'll get the volume of the whole thing. So the volume equation is 1/3 base times height. And I'm going to use that twice. I'm going to find the whole cone, and then if I take away the top part, that leaves me the volume of that. Agreed? So I have the big cone. I have 1/3 base times height, so that's pi r squared. So pi r squared, that's 256 pi, because that's 16 pi. So 1/3 pi r squared. Pi r squared, we got that? Times the height of the entire cone, which is, what's the actual height, not the slant height? 12. Good.
Hey, it's a
And then I'm going to subtract the small cone on top. So that's 1/3 base times height. So pi r squared. So I have pi r squared, so that's 16 pi. And then the height of the small cone's how much?
3.
3. Oh, this will work out pretty nicely. So 3 goes into 12 4 times. What's 4 times 256?
1,024.
How much?
1,024.
Thank you. Pi. And then this will work nicely. Those cancel, so that minus 16 pi. So this should give me 1,008 pi cubic units. Is that what the answers are? Are they? Sweet. No. So surface area for number 9, we have 570. 572. Oh, I can't add. There we go. That should be a 572 because if I add that correctly. And then is the 1,008 right?
Yes.
Okay, cool. That's a tougher problem. I really don't think we would give you one that tough on the exam. Okay, but that's a tough problem. That was the extra credit problem on the last test. Okay, that's a tough problem. There's a lot of meat to that problem. In my opinion, I feel that if I had given that problem on the very last test, and that would have been the only problem on the test, that would have satisfied about everything about surface area and volume of cones that you would ever have to know. But
Is there a question like that on the final?
I see.
You said
That was what was the extra credit on the test. I don't think I would throw an extra credit on the final exam.
So you still haven't made the final?
No.
Or do you just get the final?
I get it. They just haven't given it to me yet. They hide it from me. It's a scavenger hunt. I walk in on Monday morning. You're getting warmer. It's getting colder. And after 45 minutes of that, then I find it. Yeah,
So this is all Scantron, or is there also short?
a little bit of both. I would say the Scantron, the multiple choice portion will be a larger section than the non-multiple choice section. Yeah.
Are there any proofs?
No. And if there are, we'll do them as a class. Yeah.
Can we go over a question from the review?
Yeah, whatever you want. This is for you guys.
Can you do 1A or 1D on review 4?
Review 4.
Yeah, 1D.
Review 4. 1D.
Yeah.
Okay.
1A.
And A?
Yeah.
A and D?
Yeah.
Okay.
And just so you know, I'm recording this. Yesterday and today, you're going to be like hour and 20 minutes worth of video. So 1A, we have this. And then 1D, and this is off of the semester for review 4. All right. So the general equation for a circle, when it's like this, so the center is going to be h comma k. It's always opposite values of what's grouped. And then r is equal to the radius. Okay? So, first problem, my center is going to be at 3 comma negative 1, excuse me. What's my radius have to be? No. This is r squared right now, so that has to be 2. Okay? Is that all right? So that one's done. So on this one, I'm going to break it up a little bit. So I have x squared minus 2x. I'm going to leave a space plus y squared minus 8y. I'm going to subtract that 3 to bring it over, so this is going to become 8. Are you okay with the math I've done so far? I've also made spaces. When you complete the square, it is this easy. This is you say, what is half of this? 1. What's 1 squared? 1. If I add 1, I add 1. Okay? What is half of 8? 4. What's 4 squared? 16. If I add 16 here, I have to add 16 here. So over on this side, this is going to give me 25. Is that all right so far? This is now a perfect square trinomial. So x minus 1 and x minus 1 would be what I'd have to FOIL together to get this. Which means that's x minus 1 quantity squared. Agree? Plus, this is also a perfect square trinomial. So that's going to be y what? Y minus 4 and y minus 4. Good. Which means I have y minus 4 quantity squared. Now I know my center is 1 comma 4 and my radius is 5. Yep. That's tougher. I don't know if we're going to have you necessarily complete the square. I love completing the square. It's my favorite thing to do in algebra.
It's not hard, I just did a review.
Right. Yeah.
Thank you.
Yes, absolutely. Anything on the review, anything more, anything less. It's all for you. It doesn't matter which review, you just have to tell me which one it's on and then what number. Yeah. Review 5. Number 24. It's got the 2 cutouts of the circle. Okay. So this is number 24 on review 5. So I have a square. I have a quarter circle cut out of each. And they want us to find the shaded region. Just pretend I shaded really well for y'all. So I know that this is an 8 and this is an 8. So the total area of the square is going to be 64 square units. Agreed? Now what I want to do is I have a quarter circle in one corner and a quarter circle in the other corner. Right? So I have a half of a circle I'm taking away. So I think they told us that these are all equivalent like this as you go around. I believe if you look at your sheet that has all those marked. So that means that if this is 8, then this has to be a 4, which is a radius of a circle. So what I need to do is I need to go minus half a circle to get to the answer. Agreed? So if I wanted to find the area of a circle, that's pi r squared. So I have 16 pi. But I just said between these two, how much of a circle do we have? Half. Right? So then I'm going to go 64 minus 8 pi, leave it in pi, square units. Right? What else from our review? Anything you want? I don't know if we're going to come across law of sines and law of cosines. I didn't see it anywhere on the review, but did any of you come across it, do you think? Now, you might have to do second sine or second cosine or second tangent to figure out an angle, or you might have to use sine, cosine, or tangent in order to solve a sine, but I didn't see anywhere on the review law of sines or law of cosines. You alright back there? Just throwing stuff around. Darn class hard.
What is N2 find you? N minus 2.
What's the angle?
Don't find the
Just n minus 2?
Yeah, okay.
So you'd have to go n minus 2 times 180, and that would give you the sum of all the angles of any any polygon, including regular. If it's regular, if you go divided by n, that would find you what each of the interior angles is equal to.
Just divide by 2.
Yes, find the angle.
No, that's right.
I have another. On review 4, can you do number 14?
4. Number 14. Yeah. Review 4, number 14. I got to work this one out a couple times. I don't know if I did it yesterday or not, but happy to do it again. Let's see. This is x minus 2, and this is x, and this is x minus 1, and this is x plus 1. All right. So what we have to remember is this rule here. If I had A, B, C, and D, it's going to be A times B is equal to C times D. That's going to be my rule. So that might be something you put on your card. So with that known, I'm going to go x times x minus 2. And then I'm going to go x plus 1 times x minus 1. Is that okay so far? Do the math. I get x squared minus 2x. FOIL that, I get x squared minus 1. Remember the O and the I fall out. I can subtract x squared from both sides, so those cancel. So I get negative 2x equals negative 1. So x equals half. Yeah. Man, 6th period, you guys are awesome today. 5th period, they're off. Every which way. Kid climbing up through the ceiling. Hey, what's up, dude?
Wait, can you actually climb into the ceiling through these panels?
Yeah, I think he's up there still.
Probably can't support your body. I
You just
don't
have
know.
to-
Could they support a body?
I don't know. You have to watch the movie
Breakfast Club?
Breakfast Club. Yeah. Yes.
Like,
Oh, really?
We used to have these in our basement.
The diagonal equation like n times n minus 2.
Man. Hang on, I have to
He doesn't know the equations, he just does the
yeah. So here, we can figure it out. So we're trying to figure out how many diagonals. So once we have
It's n times n minus 2
n
over
times n minus 2 over what?
n times n minus 2 over 3, right?
Is
Or
that what it is?
the other way around, where it's n times n minus 3 over 2? No, it's n times n minus 2 over 3, because...
That?
No, it's
Well,
n times n minus 3 over 2.
It's n times n minus 3 over 2.
Because that's
Three.
the only way the triangles would work.
I know, 'cause
All right. Well, let's make sure that's right.
I know
so
that's right. Looked
I
at it.
have 1, 2. So I have 2 green. I have 1, 2 of the red. I have 1.
1. Yeah, 5 and then 5 times 5.
So,
Minus 3 is 2. Yeah,
that's
5.
it. So there's 5 there. So then I go 5
Times 2.
5 minus 3 over 2. So that's 5 times 2 over 2. So that's 10 over 2, which is 5.
Or you could have just,
So-
or the 2's could have canceled each other out.
Yeah, so
Okay, so then
that'd be a good one to know. So
What's the angle equation?
so that's for the diagonals, right?
Yeah.
So to find the angles, the angles total of any polygon, any convex polygon. We have not done any concave. Convex just means all the points are pointing outward, so it doesn't have to be regular. So it doesn't have to is n minus 2 times 180. That would be the sum of all angles. If it happened to be a regular polygon, meaning all the angles and all the sides are the exact same, if you want n minus 2 times 180 divided by n, that would get you the individual angles. Which seems like we've been doing a lot of the pentagon, which is 108, or the hexagon, which is 120. I know we've done others, but the ones that keep coming up are the pentagon and the hexagon.
We can do hexagons because so much easier because of the radius.
Do what?
We can do all hexagons on the bottom.
You got it. Just, if it's a pentagon, just add an extra dot. And make, draw your own.
I think that would get things off.
Alright,
You'd get bonus points for creativity. I just can't guarantee you it would equate to the points lost. You know,
42.
42.
42. That's the answer to all the problems. So
Oh.
You look so scared.
I was like, there's a number 42. So we need to put the disclaimer as far as these note cards go. You cannot glue your cell phone to it. I had a student ask if she could have blue and red transparencies so you could put the 3D glasses on and it would stand out to you.
that'd be so cool. Because then you could have like the dimensions of like the three-dimensional shapes. You could like see it. That'd be so cool.
That's
So
interesting.
if you are going to tape something to this, then that area, that piece of paper taped to this, you can't have something underneath it where you lift it up. You can't make a flip book out of it.
That'd be a good idea.
Why not?
Or just write really, really fast.
What I have found is anytime, and y'all are going to hate me for this, but anytime we give you the opportunity to do this, you actually wind up not even using them.
It's just a better study method because then you write everything down.
Right, it's just our way of convincing you how to study.
No, you can.
You see, I know that, so I
Mine's
don't
so
do it.
colorful.
Yours is awesome.
So small. Yours is like yours.
I have to like put lines in between. Or else
Yeah, I wrote way too
I think
small.
that.
I wrote pretty big, but I just color coded it so each one was different. So I'm not like so surface. Okay, I have to do all these circles now. Same. They're not hard.
Any more of the review you want to go over, or are we pretty much chill?
You have to chill.
I'm going to stop filming.